Go. Before we start, I want to remind you, Friday, a week from today, is going to be quiz number 2. Quiz number 2, it'll cover days, what day are we on now, 10? So day 8, 10, and 12. All right, next Friday, days 8, 10, and 12 are going to be quizzed on for quiz 2. All right, this is not on the day 10 notes, but I would like you guys to add it in for me. All right, somewhere at the top of the page. Some conversions that we're familiar with so far in this unit. And you guys at home, be ready, because I'm calling on numbers once again. I'm not going to stop this all year, making sure we're doing something at home. All right, so rectangular to polar. You guys should be aware of 2 equations we've done already. The first one involves x. We did this for quiz 1. If you wanted to find the x coordinate, anybody remember what we would, what x was equal to? R cosine theta. Perfect. All right, so rectangular, we have an x, and then in polar, we have its version, which is r cosine theta. And then we also had one for y. What was y equal to? R, not cosine, but sine theta. I'm reviewing these with you because today, every time you see an x, you're going to plug in r cosine theta. Every time you see a y, you're going to plug in r sine theta. We're going to substitute them in today. Last one, which you're not familiar with, and I have not gone over all year, is I want you to be on the lookout for this. Sine squared theta. If you see sine squared theta plus cosine squared theta, if you see this anytime today, we can replace that whole thing with a 1. It's equal to 1. Okay, so anytime today we see sine squared theta plus cosine squared, both sine and cosine are squared, we can substitute in a 1 for it instead. All right, it's going to get difficult today. This second part is a real challenge. All right, and looking at some of your assignments yesterday, we got some work to do before next Friday. All right, here we go. Number 1. Convert x equals 7 to a polar equation. So this is in rectangular. Not that you guys need to write this down or know it, but that, because it's x, and I just see x, that's in rectangular right now. That's a rectangular equation. And I want to turn it to polar. Anytime you have a polar equation, final answer should be r equals something. R all by itself is r equals something, all right? I know in equations in polar form, if it says r equals, r is all by itself. And you will notice some things that we set up today, r will not be by itself. So I need your help getting it by itself. Any polar equation, any answer we have for today in polar should be r equals this, the equation. All right, we ready to go? X equals 7. Let's turn it into polar form. You guys see what variable up there? Don't say a word. Here we go. What variable do we see up there in that rectangular equation? Let's get it started. Liz, what variable you see in that equation?
X.
X. And we just said anytime I see an X, what can we substitute in for polar form? We can put in what for X? What's X equal to here, Liz, in polar form?
R cos theta.
Yep, so I'm just going to substitute it in. Where I see the X, R cosine theta equals 7. I substitute that in every time I see an X. All right, looks good. But if this is going to be a polar form, what's got to be all by itself? The R. So now I need your help using your algebra skills, which I know all of you have, to get R by itself now. I need to get R all by itself. Well, what's with the R? Cosine theta.
It's being can I say it?
What's happening between the two, Caroline, before we get to the answer?
They're being multiplied.
And your whole entire life, if you want to undo multiplication, what do? Divide. So I should divide both sides by what, Caroline?
Cosine theta.
There you go. If you want to get R by itself, divide both sides by cosine theta. Get the r by itself because it's not a polar equation unless it's r equals, and there's nothing I can do here. You guys are done. 7 over cosine theta. Now this is brand new. You're going to be nervous if you did this right. So we're going to check to see if you did it right. The graphs, the original one, the graph for the original, and the graph for what I think is the answer should match on the polar and rectangular. And that's why you guys have those 2 tabs up right now. So let's go to the rectangular one first. Okay, everyone go to the rectangular grid first. This is a quick check every time. You guys are probably, what I would emphasize is, where is it? No, this is blocking me. Get out of here. There we go. You guys should have a key, and it's still blocking. There it is. You guys should have a keyboard in the bottom left-hand corner. And instead of using your own keyboard, I recommend using that one. All right, so what are we going to type in? What was our rectangular equation? Okay, you got the X button right here. X, you even got a darn equal sign down here too, below the numbers. X equals 7. Everyone see the red line, the vertical red line that appears. That's what that graph looks like on your old school rectangular grid. Good? All right, let's see if I see the same exact graph, same exact line on the polar grid. Now here's where you type in your answer. R equals, I don't think it's got an R though. I got to do this every time. So you might have to actually write in R.
You can do the ABC.
Oh, I got an ABC there. Thanks. Look at you. R. Where's it? See, now I got to.
Hit 1, 2, 3. On the left. Bottom. Go back to the.
Got it. R.
Oh, I thought you were.
Relax. Relax. I'm the one with the pen here. So R equals. What did we thought it was what? 7 over cosine theta. It's already 7 divided by, look at that. Now, if you want cosine, you got to go under function. You can actually type in the word COS, or you can go under the functions button, and you guys see cosine right there. Now, here's the crazy part. How do you get theta? You literally type in the word theta right now. THETA, and watch what pops up.
Whoa.
Hello! THETA, theta. And then look at your graph now. Notice anything? Same vertical line going through 7. So we do have this correct equation then, because it matched the rectangular one. So this is how I'm going to have you guys check. All right? Both are the same. Any questions at home? So substitute in, get R by itself. That's what we're doing today to get it into polar form. Substitute in, get R by itself. All right, let's keep going then. Any questions, comments on number 1? All right, let's keep grinding away. A little more complicated next. Oh, now what do we see in this one? Here we go. Got some work to do. Bassett, what variables do we see in this one? Okay, maybe not today. I can't see everyone on my screen. 13, here we go. Eliana, what variables do you see in this one?
It's both X and Y.
Okay, you're only going to do X for me. What do I substitute in for X?
R cosine theta.
R cosine theta. Here we go. Plus, now I need to know, what do we substitute in for Y? Look back at the beginning of your notes. Hunter, what do I substitute in for Y? Can you hear me, Hunter? What do you substitute in for Y? All right, let's keep going. Not letting me unmute. All right, no problem. Colin, what do you substitute in for Y?
R sine theta.
Good. R sine theta equals 5. Good. Now we substitute it in. Now we got to try to get R by itself. Oh, yikes. Huh? Oh, boy. This isn't... Ooh, I got 2 R's, though. I need it down to 1. Oh, boy. So I just can't divide by cosine because I'll still have the other R with the sine. Oh, boy. Anybody see anything? Possibly we could... I want to hear from you guys first before I say this is how we're going to do it. How I can get those 2 R's into 1 R. Caroline, you got something?
Square them.
If I square them, though, I'm going to have R squared, though. I didn't get rid of it. You see what I mean, Caroline?
Yeah.
If you square it, then I'm going to have R squared, and I still didn't solve my problem, which is to try to get 1 R. See, do you see I have 2 R's up there, Caroline, and everybody else? I got 2 of them up there. I need it 1. I need to make it into 1. Any other suggestions before I show you how we're going to accomplish this?
Divide by cosine theta plus sine theta.
Cosine theta plus sine. If I do that, though, Nick, I got to divide each one by that. So if I do it here, ready? I see what you're saying, but I got to do it just like that to that one. And that doesn't, might get rid of the cosines, but not the sine at all. See what I mean? All right, I like the suggestion.
This is gonna sound so stupid.
No, I'm sure it's not. Go ahead.
Square root it and make it, because like square root of 1 is 1. I don't know. That was just a thought.
Okay, if I take the square root of this, it's just the square root of R cosine theta. It doesn't disappear, right? I want one of those R's to disappear.
Oh, no, that's not, I was gonna say add them together and then.
I can't add them together though, right? Because that's got to. All right, I love all this. What's up, Caroline? One more suggestion.
Negative.
Make them negative. Then I'll just have negative R and negative R.
No.
Okay, everyone ready?
Yeah.
Factor. And don't get nuts on me and start groaning. They both have an R in it, right? Take it out. Remember the old GCF method? Take an R out. Watch, ready? When I take an R out, these two just become an R on the outside. I'm factoring out an R. So take an R from both of them. What's inside my parenthesis now? Help me with that. Nick, you ready? I take an R from R cosine theta. What's left? Cosine theta. Take an R from R sine theta. What's left? Done. Everyone see how 2 just became 1 by factoring. Hey, guys, if you're confused, this is all I'm doing. 2x plus 4. Oh, take out a 2. That's x plus 2. That's all I'm doing. Okay, it was your old greatest common factor when you guys used to factor back in algebra 1 and 2. All right, now I got 1 R by itself. How do I get rid of that rest of that mumbo jumbo with it? How do I get rid of what's inside the parentheses? You'll be right. I bet you'll guess, but you'll be right. Divide it out. If R is being multiplied by all that, divide it to undo it. So we're just going to divide everything by cosine theta plus sine theta. Divide out everything that's with it. So what's left on the left side? My single R. Perfect. That's what I want every polar equation to be. R equals 5 over, don't try to be a hero. This is it. There's nothing fancy we can do here. All right, let's check if we're right, because I know we're right, obviously, but you guys are going to have to check your assignment on Monday by going to Desmos. All right, so here we go. Let's clean this up. So x plus y equals 5. So hopefully my polar graph looks like that diagonal line. All right, over here now, go to the polar grid. We had 5 divided by, remember you can go to the functions button. What was it? It doesn't matter the order, but cosine. Now I got to type it in. Theta theta plus sine. You think they'd have a theta button up here? Oh, we got ourselves a diagonal line, just like the one we had on the rectangular. Perfect. Okay, so be ready. Be ready to start factoring out r's now, all right? Especially if there's two of them on the same side. Any questions from you guys before we only got two more, but it goes up in difficulty. Anything? All right, let's do it. X squared plus y squared equals 9. What's that in polar form? So r equals what? All right, same thing. What do you see in there? See any variables we can substitute in for? Let's start there. Any substitutions I can make? Here we go, Liz, back to you. Any variables I can substitute in for?
X and Y.
Good, X and Y. So there's going to be two substitutions. Next person, tell me what I'm going to substitute in for X. Eliana, what do I substitute in for X?
R cosine theta.
Okay, now we see a squared with it. So let me show you how to write that. All right, I'm still going to do R cosine theta, but I'm going to put parentheses around it because I'm about to square it all. That's how I write it. I'll show you how to treat it after I'm done. Plus, what's getting plugged in for, substituted in for Y? 8, Colin, back to you. What's getting substituted in for Y?
R sine theta squared.
Yep, make sure we get parentheses around it and square the parentheses. Equals 9. And I'll stop there for everybody to catch up. That's just the substitution part. Now comes the algebra, getting R by itself. All right, so how do I take care of these squaring the parentheses? You square everything inside. You square everything inside. So for instance, R cosine squared theta, you're going to square the R, and you're going to square cosine theta, which looks like this. Okay, you square everything inside. So the R gets squared and the cosine gets squared. Same thing with the sine. The R gets squared, the sine gets squared. Equals 9. I know that looks intimidating, but based on what we did last problem, I think you guys might be okay. I need to get a single R by itself. Look at what we did last problem. Can Matt help us at all with this one? Because I have R squared twice, and that's a problem. I just need one R once. How can I make the two R squareds there into one? Just look. I'm not going to call on anybody here, but just like I did the last problem. Last problem, we took out an R because they were in both. Now, instead, I'm going to take out R squared. I'm going to take out R squared instead of R because they're in both. Now I'm going to call on somebody, hey, when I take an R squared from both, what's left inside my parentheses? So take an R squared from both. Ready to go, Ella?
Yeah.
What's left in the parentheses?
Cosine squared theta plus sine squared theta.
There you go. Equals 9.
Yeah.
Yep. Okay, the first time we've occurred, this has happened. It's going to happen more. Look at what you wrote at the top of your page today, in front of your notes. Cosine squared and sine squared when I add it. Cosine squared and sine squared. That's the same as what? 1. Okay, when I see cosine squared and sine squared on the same side, that's the same thing as me writing it's equal to 1. There it is. That's equal to 1. So what am I just left with on the left side now? Oh, we're getting there. R squared now equals 9. Oh, we're getting there. But R squared is not good enough, right? It's got to be R equals. Okay, guys, come on now. What's next? Yeah, take the square root of both sides, right? Take the square root of both sides. R equals. That doesn't look right, does it? R equals 3. I don't know. We'll check though. Seems like there should be more to it, right? Based on the last two problems. But hey, watch what happens now. All right, go ahead. Let's check. Let's check on our polar grid and our coordinate grid. So let's go rectangular first. Let's go rectangular. Let's get rid of this. X, if you guys are working, everyone see where it says a squared to the right of y? That's where you can square your x. So x squared plus y squared equals 9, right? Oh, we got ourselves a little circle action, huh? And you know what's nice about these calculators versus the ones you have? It doesn't have to be y equals. We just type that thing right in and we're good. Think we're going to get a circle on the polar grid? R equals 3. Oh, and conveniently, look where that circle goes out to, Nick. 3. Thanks. I know. You're excited. What?
He's a flame.
Or you just
So you basically just said he has no heart.
No.
Which is fine
It's
because
stretching it.
that's what we have in common
At
then.
least he's good at this stuff.
Stretching it, Nick. I would never say that.
Any questions from you guys at home? Because this isn't even the top of the mountain yet. Any issues what we just did? Substitute. I factored out an r squared, and then hey, if you see cosine squared plus sine squared, put a 1 in there instead. You ready for the last one? The beefy one? You might want to leave, Isaiah.
Yeah, I think I might want to.
Okay, you might want to leave here.
I'm gonna be called on. I know.
It knows.
Oh, it does.
All right, you guys see x's and y's, right? You know what to substitute in. Here we go. Everywhere you see an x in this equation, what are you substituting in? Everywhere I see an x, what am I substituting in for? Here we go. Caroline, what do you want to substitute in for x?
R cosine theta.
Okay, here we go. So let me do it for the first one. R cosine theta all squared. And then over here on the right, 4 r cosine theta. What? I don't think you were muted there. I didn't think you were muted there. What's the problem, Caroline?
No, I did the problem without doing that.
Oh, so you tried to be superstar and go ahead.
Well, I wasn't going to tell anyone.
Okay. Everyone all right on how I wrote it specifically on the right side? All I do is plug in r cosine theta. There's nothing to distribute. All right, it's all multiplication. All right, what are you plugging in for y so we can get going here? What's getting plugged in for y? Caroline, again.
R sine theta squared.
R sine theta all squared. Good. All right, we did this last problem. Okay, we square. Anytime we're squaring outside the parentheses, we square everything inside. So we got r squared cosine squared theta plus r squared sine squared theta. Nothing yet on the other side. And if you're thinking, yes, this problem looks very familiar from the last one, you're correct. But there is an r on the other side now. So eventually we're going to have to deal with that. Okay, I have r squared and r squared on the left side twice. How do I make it into 1 now? Both r squareds. I just want one of them. What do I need to do? What have I been doing? Eliana, last one for you. What have I been doing to get those 2 into 1?
You factor it out
There-
and put it in front of the parentheses.
Yep, and then what's in the parentheses when I take out r squared?
Cosine squared theta plus sine squared theta.
There you go. You can do this. You can do this. Still haven't touched the right side yet. There's nothing I can do there. Oh, everyone, I know, and this is just good. We have to get used to this. Oh, I see cosine squared plus sine squared. I know what that's equal to. What's that equal to? Cosine squared plus sine squared. Kian, cosine squared plus sine squared. What's it the same as?
X plus Y.
Oh, whoa. Did we write at the very beginning here? Cosine squared plus sine squared.
No.
Here we go.
X squared plus y squared.
Hold on. We're just throwing out stuff. Sine squared plus cosine squared. Anytime I see that, I substitute in what?
1.
1. All right. I don't want to go, kid. I don't want to go back. If you plug in x and y, I'm going backwards. All right. I don't want to put x and y back in. All right. I don't want to put them back in. So I'm going to put in a 1. We okay? Before now we come to the challenge is what the heck to do next. Left side, r squared. Right side, 4r cosine theta. I get it. Last problem, you took the square root because you could. But watch me do that right now. Watch me take the square root. Don't write it on your paper. All right, take the square root. I'll get r. I get that. But you take the square root over here. Is that going to eliminate the r on that side? No, it's not. It's not going to eliminate the r on that side. But I need it to be eliminated. So taking the square root when there's an r on both sides, not the best idea. Anybody got a better idea?
Divide.
Divide by?
R.
Yeah?
Good job, Isaiah.
Wow, yeah.
I got something.
How about we end up Friday on that one? Isaiah in class just said, divide, instead of taking the square root, watch. Divide that left side by r, and whatever you do on one side, do to the other side. So divide it by r, and watch what happens. What's on the left side now, Isaiah? Come on.
On the left side, r to the third. Wait, no, just r.
R
R
equals
4 cos theta. 4 cosine theta.
It is without a doubt. I don't know how many of you have seen this watched Old School when they're in the debate portion and Frank the Tank he just blacks out and just starts spewing off this genius stuff, and all of a sudden he wakes up and he's back to his regular normal self. I feel like you have a couple of those moments as well. Wait a second, where am I?
Without a doubt, yeah.
Where am I? Cos? Okay, we're back to Isaiah.
R cubed.
All right. Let's see. Do they look the same? Let's go back. Use this on Monday, please. If you're home, use this on Monday to check. Well, I shouldn't have. Anna, you know what? You're pretty talkative today.
I'm just trying to help.
Yeah, you're pretty. Yeah. Why don't we do this, Mr. Carlino? I'm actually shocked that you're here today. It's a Friday. Figured you'd be home. I know, I'm proud of all 4 of you. So that's what x squared plus y squared equals 4x looks like. And then what about, I'll keep the r. R equals, what do we say? 4 cosine theta. 4 cosine theta theta. And look at that. Perfect. We have our same looking circle. And yes, if you're asking, we will be graphing these eventually after the quiz. All right, that's our last thing we got to do is graph some of these. Questions from you guys? Monday, you're not going to see anything different. Substitute in, factor. Do you plug in a 1? Maybe take the square root, maybe divide both sides by r. All right, have a great weekend. Nothing stronger than ginger ale. Behave, be smart.